So the denominator is already factored. You have to factor the denominator if you want to decompose a fraction, a rational expression. So this one is factored all the way, and this one is factored all the way. So what we do is we rewrite it. And on the other side, we're going to put a factor on the bottom of each of these. So we have x minus 1, and then we have x squared plus x plus 1. For above this one, we just have to put an a on top. But above this one, we have to put an a bx plus c.
Why?
Because it has to be 1 degree less than the denominator.
Oh, understood.
Okay, now I'm going to multiply both sides by the common denominator, which is x minus 1 and x squared plus x plus 1. When I multiply it to the first one, the denominator just cancels out. So I get x. When I multiply it to the second term, we get a times x squared plus x plus 1. And that's because this guy cancels out with this guy. But when I multiply this guy to the last one, we just have bx plus c, and we're multiplying him by x minus 1. All right, now let's do it. Now, before, what we would do is we would pick x values to cancel out some of the terms. But when we get to this point and we have all these x squareds and everything, all you got to do is first simplify the side and then combine like terms. And so I'm distributing the a, and then I got to distribute this stuff over here. You can use the box, the area method or the tabular method to multiply them, or you can just do rainbows. So I get bx squared minus bx, and then I get cx, and then I get c minus 1. So I get negative c. All right then, combine like terms. We got x squared right here, x squared right, or bx squared right there. So we get a plus b x squared. All right, next we got our x terms. We have some x terms over here. Heck yeah, we do. We have an ax right there. We have a bx right there, and a cx. Oh my gosh! Now that b's a negative. Don't let that mess you up. So we have a minus b plus c, and we have an x right there. Do we have any constants? Yeah. Yes. Let's add our constants together. We have a minus c. Okay. So why are we doing all that? Because now on this side, I have to match up all those terms. So I have 0x squared plus 1x plus 0. Why did you put that guy and that guy? They weren't there before. Yeah, I know. I'm just doing it for teaching purposes. So if I'm trying to line up these terms, what is a plus b supposed to equal?
0.
And what is a minus b plus c supposed to equal? And a minus c. Okay, so we got to be a little clever here. Let's see if we can figure these out. A plus b equals 0. And then we got a minus b plus c equals uno. And then we have the last one, a minus c equals 0. Oh, check that out. A equals c. Hey, that's important to know. This will really help us out here. If a equals c, we can get these other ones done really quickly.
I think c equals 1.
Oh, you do you?
I learned.
All right, I'm going to take this c out right here and put an a. So I get a minus b plus a equals uno. All right, a and a. So how do I rewrite that?
2a.
2a. So I get 2a minus b equals 1. And then I'm going to put a plus b equals 0 right underneath it, because right here, people, I see a system of equations. Let's add these dudes together. The b's cancel out. We get 3a equals 1. What does a equal? 1/3. Oh, if a is 1/3, that means c would also be 1/3. But what would b equal?
2/3.
Let's see. If I plug in a to right here, wouldn't you just subtract it to the other side? And wouldn't you get b equals negative 1/3?
Yeah.
Heck yeah, diggity dog. So now we just got to plug in our 1/3s to all these. We have a 1/3 right here. We have a negative 1/3 right here. And we have a 1/3 right here. I think in the book they actually factor out all the 1/3s and put them out in front, but I'm just going to leave it like so. Actually, that would make it more sense, huh? Because then we wouldn't have fractions inside fractions.
1/3.
Yeah, so we could rewrite the answer as 1/3. We have 1 over x minus 1 plus negative x plus 1 over x squared plus x plus 1.
Wait.